This video is sponsored by Brilliant. Hey guys, this looks like a fun one. It says the square and the rectangle intersect at the center of the semicircle. What is the total yellow area? This is day 22 of our Aggvent calendar. For the month of December, we're going to do 31 Katrina Ag puzzles in 31 days. And if you want to try this one, pause it right now because I'm going to solve it in 3, 2, 1. First, let's copy down the square and the rectangle. Now let's label the area of the square X and the area of the rectangle Y. And now we can write an equation for the yellow area. This part of the yellow will be equal to X minus 15. And then this part of the yellow will be equal to Y minus 15. So the yellow area will be equal to X minus 15 plus Y minus 15. And we can rearrange some things and simplify it to X plus Y minus 30. This looks important. Let's put a box around it. And let's move it down here. Next, let's draw the radius of the semicircle from here to here. And that'll split this pink area up into 2 triangles. Let's give this triangle an area of A and this triangle an area of B. And then we know the area A plus the area B is going to equal this area of 15. This also looks important. Let's put a box around it and move it down here. Next, let's color this triangle down here blue and let's compare it to the other blue triangle. These 2 angles are both right angles, and that's because they're both angles of this square. And then from here, let's highlight this radius of the semicircle and this radius of the semicircle. Both of these will be the same length because they're both radii of the semicircle. And then last, let's focus on this side right here and this side right here. These are both sides of the same square, so they will also be equal to each other. And here's our 2 triangles brought down here. If we label each of these points, we can say triangle NDY is congruent to triangle SKY. And that is because of the HL theorem. The HL stands for hypotenuse leg. That means if you have 2 right triangles and they have a matching hypotenuse and also a matching leg, you know the 2 triangles are congruent. And now that we know these are congruent, we can say that this base is equal to this base. And the reason for that is CPCTC. This stands for corresponding parts of congruent triangles are congruent. That means we have 2 triangles that we know are congruent. These corresponding parts will also be congruent. So if we go back to our diagram, these 2 sides would be this side and this side. Something else we know, since these are congruent triangles, we know their areas will be the same. So this one also has an area of A. Let's clean this up and let's clean this up. Now from here, let's draw this line perpendicular to this side. And let's color in these triangles. These 2 sides are the same thing as these 2 sides. These other 2 blue triangles have the same parts as these blue triangles. So they're all going to have an area of A. And now I think we're done with all these dash marks. Let's bring this up here, and now we have another fun equation to write. This square has an area of X, but it also has an area of 4A. So we can write X is equal to 4A. And let's move it down here. All right, let's return this to this point. And now let's connect this radius. And highlight this triangle here, and let's compare these 2 red triangles. Both of these are right angles because they're angles of the rectangle. Each of these are a radius of the semicircle, so those will also have the same length. And then each of these are a height of the rectangle, so those will also be congruent. Now let's focus on these 2 triangles. Once again, because of HL theorem, these are congruent triangles and they'll have the same area. So this area will also be B. And then once again, because of CPCTC, these 2 bases will also have the same length. So let's update these up here. These will both have an area of B and these 2 sides will be the same length. And now I think we're done with this. And we can clean this up a little bit. From here, let's connect this line perpendicular to this side and focus on these 2 triangles. This side and this side are the same as this side and this side. And now these 2 red triangles are the same as these 2 red triangles, so they will also have an area of B. And now we're done with all these markings. Let's grab this rectangle and bring it up here. The area of Y is going to be the same thing as the area of 4B. And now let's put this back down here and return this back to here. Now I think we have everything we need to finish. First, let's add these 2 rows together. I just remembered I get asked all the time, why can we just add one row to another row? Let me see if I can come up with an explanation. Let's say we make X a green hexagon. Since 4A is equal to X, we could also make it a green hexagon. If we go back up here to Y equals 4B, if we add the same thing to both sides of the equation, we're not going to change anything. So let's add a green hexagon to both sides of the equation. And let's call this green hexagon X and this green hexagon 4A. And that's the same thing as adding this row to this row. I hope that visual helps to explain it. So if we add these together and keep them in alphabetical order, we'll have X plus Y is equal to 4A plus 4B. On the right-hand side, both of these contain a 4, so let's factor out that 4. If we pull a 4 out of this, on the inside we'll have a plus b. And earlier we found out a plus b is equal to 15, so let's plug in 15 for a plus b. And 4 times 15 is equal to 60. So we've now figured out that x plus y is equal to 60. Well, this is what we needed to find the yellow area. In the place of this x plus y, let's plug in 60. 60 minus 30 is equal to 30, and let's give it a label of units squared. This is the answer to our question. In this problem, the yellow area is equal to 30 units squared. How exciting. Here's the puzzle for day 23. We're given 2 regular hexagons with an area of 6. And it wants to know what is the total shaded area. I think this would be a brilliant bonus question. Speaking of brilliant, let's talk about Brilliant. Brilliant has thousands of lessons in math, data analysis, programming, and AI. And all of them are interactive, which is the most effective way to learn. I really enjoyed doing these regular geometry problems, and that is what Brilliant is all about. Setting a daily habit of learning and going through challenges. It covers so many different topics and it's presented really well. You'll learn so many new things and enjoy doing it. If you want to try Brilliant.org, there is a free trial. You can visit Brilliant.org/Andymath or click on the link in the description. You can also get 20% off an annual premium plan. How exciting.